Well, hi, good morning. It's July 5th. Thank you so much for joining me in my shop today for another run at this radio. So I've aligned the radio. I've done it rather roughly, just using my ear and just kind of doing a quick job to make sure if there's anything that's way out of whack, at least I've got it more in whack. I've done that and the radio's operating quite well. So what I want to do today is look more closely at the alignment and make sure things are as good as they reasonably can be in an old radio like this before I send this guy off. So in doing that, one of the procedures for the alignment of this radio, it's written in this paragraph here, is to attach temporarily another tuning capacitor to the tuning capacitor that's in there to compensate for some kind of effect that takes place in this radio when you're aligning it. And the effect is, when you go to make the antenna tuning adjustment, the local oscillator will drift a bit this way or that way. So this procedure they are suggesting in the manual is a way to get around this and to end up in the best alignment possible. I'm looking for another way yet to do it. This procedure was written in the 1940s. It's now 2023, and I've got some other opportunities here to become aware of the operation of the radio that just didn't exist back in the 1940s. I'd like to use those opportunities, and I really like to avoid following the procedure that's suggested in the manual there if I can. So I think part of the secret of success here is being able to visualize or be aware somehow of where the front end tuning of the radio is at the same time you're watching the local oscillator and other elements of the radio, and get some kind of a complete picture of how it's operating. And from there, should be able to make adjustments following the visual indications that I'm looking at. That's what I'm hoping for anyway, and bring the radio into perfect alignment, or as perfect as you can expect from such an old radio like this. So the two tools I have to do this, one of them is a sweep, two or three tools. A sweep generator, that's this guy, generating a sweep frequency coming out, going a lot faster than my hand. That's one. Secondly is my oscilloscope, which can visualize voltages and other things in the radio. You can see I got my scope lead just sitting here right now. And the last one, probably the most important one, and the trickiest one to interpret, is my SDR radio. The SDR radio is sitting right here. This is the antenna lead from it. And currently it's connected to that yellow coil, which is just this clip lead coiled up a few times and stuck around the grid wire coming up to the grid here, which incidentally is on its last strand at this point. It's ready to break right off. I'll probably achieve that pretty quick in doing this. So the object here is, even with the radio not switched on, I should be able to see the signal as it's passed through the radio, the swept signal or sweeping signal as it passes through the front circuits of the radio and arrive at the grid here. And that's what the coil is for. The coil is to pick up some of the signal that inevitably is going to be pumping up here, hopefully pumping up here. Now, you can think about it this way. I'm injecting a signal here from the sweep generator into the antenna terminals. It's sweeping through the receiving range of the radio, and it's suppressed except at the tuned point of the radio. It's no longer suppressed. It comes through full strength. You can think of it that way. And this will give you a curve. It's going to look, something like that. Some kind of curve that looks like this. And the peak of it is going to indicate where the front end is tuned. The front end tuning can be adjusted with these adjustments here to make it, to place it in the correct location based on the local oscillator frequency and also based on the dial setting. You get all three of those things going in the same alignment, I guess would be the word for it. That's the objective. So I'm going to show you what's on my SDR right now, and we'll talk a little bit about it. Okay, so here's the SDR output. You see here's 5 megahertz right here, and my sweep generator it only goes up to 5 megahertz, unfortunately. Now, as always with demonstrations, they fail as soon as you begin showing them. Somewhere on here is a peak from the sweep. Now, see that getting a little bigger? And I can turn the volume up here just a wee bit. This is the SDR volume. The radio itself is not switched on. So, a couple of things here. This is the edge of the sweep coming from the sweep generator. This is how high it's going, and then it's starting over again and coming through. And this is the resonance of the front end of the radio. That's my coffee alarm going off, but I'm going to ignore it. So you just ignore it too. Now I'm going to turn off the S decay here, so there's no decay in the signal. It takes a little bit to paint a nice response curve, and there you have a nice response curve here. Now we can ask ourselves, well, is this really the radio? Let's find out. So I'm going to turn the decay back on a little bit. If we turned up too high, you get that, by the way. So right down here, just one little notch up. Good. Now I'm going to tune the radio while you're watching that. Right now the radio tuning dial says about 4.3 is what it would say. And if you notice, look, this is just about 4.3 might be just in this area. It's very close. Now we're going to turn the dial, and that bump should move. There it goes. So I can't go too far this way. So this would be 5 right about here. And you can see it's right around the 5 mark. Excellent. So I'm definitely seeing a response on the SDR that's coming from the radio. The radio's tuned circuits. Of course, the red line represents where the SDR itself is tuned. So here it's tuned to where the sweep is going by, and that's why you're getting the buzz sound. If I move the tuning point up here, no buzz, because the buzz ends here. The sweep ends there. Now, the next question is, have I disturbed the radio by the way I have set things up so that this is not where it really is had I not attached the equipment? Now, what have I attached? I've attached almost nothing here. Let's just take another look at that. Just to make it really clear how I'm doing this. Again, the radio's not operating. And I've just taken this clip, it's just around the wire going to the grid cap. You know, the tube's not hot, there's nothing happening here. So I guess there'd be a little electrostatic interaction, capacitive coupling, I guess would be the right word, between the coil here, as much as it's a coil, and this wire. And that's what's actually getting enough signal to follow the lead into my radio. We see it up on the computer screen. Now another way to do this would be to hook up my scope, and can certainly be done. But I'm going to connect it here briefly. I'll just do it by hand like this, while you watch the SDR effect of what happens if you hook your scope up to the tune point. Are you disturbing the radio? That's the question. So if the radio is being disturbed, then it's going to be a false indication here. Let me just get this here. Okay, so you can see the peak is around 4.2 or so. And I'm just going to touch the scope probe to the cab here. You see it move? It's gone to the left. I'll take it off again. So hooking up the scope probe throws the radio off. And I'm going to put this on, it's on times 10. I'm going to put it on times 1. This will probably make it disappear right off the screen. Yeah, so we can think the resonant point is way off to the left. It's gone from view. Want to get off again? So the next question would be, well, what about the loop of wire I've put there? Is that, and the connection to my SDR, if I can call it a connection, is that throwing the radio off? I would think not really. I would think not much at all. I guess it has to throw it off to some degree. And the question would be to what degree. So let's do this now. I'm going to stop for a minute, and I am going to go drink some coffee, and we'll rearrange my computer screens, and we'll have some some more fun with this before we actually put it to work. Okay, so here lies the conundrum with doing this kind of work. And that is, as you connect equipment to try to examine the condition, the operating condition of the radio, the equipment disturbs the operating conditions. The moment you connect it, the disturbance happens, and when you look at your instruments, you see it in the disturbed way. When you remove the equipment, it's undisturbed, and now the radio operates differently. It's very easy to get fooled, and I'm sure in the past I've been fooled many times by connecting equipment, not realizing the impact I'm having on these fine-tuning adjustments, making adjustments. You remove the equipment, you can't necessarily tell that things have shifted again. It's not apparent. So this is the conundrum of doing this work. So that's why I'm being so careful here to find out if the technique I'm using is disturbing the radio. I'm trying anyway, because everything you try could be a disturbance in itself. So what I also want to experiment with next is going up to the high band. That's really where I want to get to, the high shortwave band. Now my sweeper ends at 5. There's the end of it right there. 5 megahertz. So I'm going to tune this up to, well, I don't know, let's say 15. That's just about where it would be here. There. 15. I'll switch to that band. And we didn't see anything happen at all, nor would I expect to. Now we're going to put the SDR up to 15. Good show. We hear something. So that sound that we hear is the sweep going by. So that's great. What I'm relying on now, even though it's beyond the range of my, let me just turn this down here. Even though it's beyond the range of the sweep generator, the sweep almost certainly has harmonics. Well, we can see it has harmonics. So along with the main frequency going, there are harmonics going up, up, up in frequency. Who knows how high? And perhaps this is how this instrument was really intended to be used. Anyway, that, if you want to use it beyond the 5, you're going to rely on a harmonic of some sort. So right now, the actual sort of base sweep frequency is roughly 2,000 hertz to 5,000 hertz. So if we multiply that by 3, then there should be something going on 6,000 to 15,000, if I've got it right. A harmonic running between 6,000 and 15,000. That's quite a range. The fact that we can hear it means it's passing the point where this red line is, which is 25 plus megacycles. But wait a minute now, what am I doing way up here? We want to be around 15. Isn't that right? Did I confuse myself? 15 is where we really want to be. Must have clicked this twice. So now we're down around 15. Now I don't hear it anymore, and you don't see much effect here now. I'm going to guess. I don't have to guess. Calculate again. So we started at 2, so it's supposed to be 6 to around 15. Well, that would certainly incorporate the area we're tuned to right now on the SDR. Why is it a no-show? That's a good question. So let's see. If we want, so to get to 15, that's either 5 times 3. Shouldn't that work? If we're maybe we're just, no, I don't know. This is the point where I kind of wander around looking at what's going on. Let's go back up there where we could hear it. Just turn the volume up a little bit here. Wasn't it right around here? Was it just some magic coincidence that we could hear it before? Okay, so those sound changes you just heard is the SDR automatically switching to different modes. AM mode to single sideband, stuff like that. Well, what's happened? I thought I was all excited there. The excitement is drained out. It's definitely sweeping. Well, I don't know. I've lost it. I've lost it. It's gone. It's disappeared. Why would it disappear? Why would I have it and now I don't? Crying out loud. That's really I was really on a roll here. And then not anymore. What is this? This looks like a broadcast station of some sort. The sidebands here. Don't know what it is. We are currently in AM mode. Yeah, that's not going to help. We're not. This is very, very wide bandwidth. So I don't know what this is. This is something curious in itself. I'm going to ignore it. When you're using an SDR, at least when I'm using the cheap SDR I have, this guy here, I get a lot of weird signals, birdies, lots of things go wrong with the SDR. If you overload the input, which I'm likely to do doing this kinds of experiments, you get all kinds of stuff showing up that you have to fish through to figure out what is really related to the radio and what is not. Well, we seem to have lost it here, so I'm going to stop the video here and figure out what has gone wrong. Okay, I managed to figure something out. So I have my sweep generator sweeping a huge amount. It's down around 5 megahertz, but then there's going to be harmonic sweeps occurring higher up in frequency. Well, you can see one of them right there. And what I did was I just narrowed down the sweep to pretty much start and stop at almost the same frequency, right around 5 megahertz, just to be specific. Here, it's starting the sweep at 5.2. And it's stopping the sweep at, it's actually going the other way around. It's at 5.1. It's actually sweeping backwards, which doesn't matter at all. You can see the small sweep range showing up. Now if I put the red line, the receive point of the SDR here, there it is. Good. Oh, we just don't want this here. We want this going by, let me just write that down. We want it going by where the radio is tuned. So we want it wide enough to cover. So the radio is tuned to roughly 15. Again, the radio is not switched on for any of this. So we really want that sweep to be crossing 15 megahertz. So what I'm going to do is I'm going to take the lower sweep, which is actually the top number, and I'm going to move it down here, and that should give a sweep, something like that. That's my theory. What happens when they do it? There we are. Perfect. Perfect, perfect. So now you can see the sweep effect. It's here. Before, when I had it broadened out so much, you couldn't really see it. It was just too weak. So I kind of focused it down like this. Now you can see the sweep range. Okay, so now we're sweeping through the right range. Now let me turn the sound off here. I'll just move the tune point over here so we don't have to listen to that. Now, what I'm hoping to see is some kind of a response curve in there. It could be quite wide too. That looks pretty flat to me. But what I'm going to do is I'm going to stop the SDK. I'm not sure what that stands for. SDK. We'll let it build up. See what we get. So that's what we get. No sign of any kind of response in the front end of the radio doing this test this way. Is there something dumb I'm doing? I don't think so. Well, the whole thing may be dumb, but so we could guess. Well, the tune point is outside the range that I'm looking at. So let me turn the sweep back on here, or the decay rather. Decay. I wish I could turn my decay off. Now, what we're going to do is expand this a little bit further and go hunting, or I could tune the radio. Would be another way. Let's try tuning the radio. That's the easy way to do it. So I tune the radio. I'm looking for something to show up, some kind of response curve to show up in here. So we'll go down in frequency very slowly. Getting bigger. Oh my gosh, there it is. There it is. So based on this test, the front end is currently tuned, right in this range. Now you see the tuning is quite broad. because of the high frequencies we're working with. So, it's a kind of a percentage of the frequency you're working with. So the higher the number, the larger the percentage number. If you follow what I'm saying. But it's in the right area now. But the radio is actually tuned to just under 14 megahertz. So it's not in the right place. Now the question would be, is what I'm doing invalid? I've disturbed the radio. Putting this little yellow coil here has disturbed the radio. And in fact, that tune point would be somewhere else if I remove the equipment, which again, it starts becoming difficult to know where it is when you don't have any equipment attached. So there are more and less sensitive places to connect equipment. Fairly safe places you could connect stuff, and the change in impedance won't throw the radio off, or won't throw it off enough to worry about. Nothing that caught my attention here is that there was an intermittent problem which I was chasing for a while, then it went away. Has it come back? Even with the radio not operating? So, what do we do now? I think we should turn on the radio and watch what happens. Would this change at all? I don't know offhand, actually. Get much stronger. It may get much stronger. No, you know what? I don't think so, because I'm looking at the grid going to the first amplifier. I'm ahead of the first amplifier. The signal can only go down from the antenna a little bit. Okay, that's not necessarily true. You can get reactive things happening. And there is a transformer involved. Let's try it out. Okay, so I'm going to turn this down. We're on the high shortwave band. We are, aren't we? Yes, we are. And the grid cap's hanging by one strand up here. That's not very good. But it is what it is. Yeah, I think we can just turn this on now. Here we go. Mr. SDR, what do you do? Power's on. The waterfall display will help a lot. It looks like it's getting a little stronger. Turn the radio up a bit. Hear the excitement when it comes. This thing should be making the same buzzing sound we heard. Oh, look at that. Wow, okay, that's really unexpected, but it's glorious. That's a glorious thing there. Well, I have to think a long time. How did that happen? Am I on the grid cap? Maybe I've misinterpreted the tube lineup. Am I not on the very first tube? Sure I am. The grid cap wire goes straight over to the tuning capacitor. How did it get like that? Maybe the tube itself now is there's an additional radiation coming from the tube. After it amplifies, the tube is radiating outwards. You know, the coil is just sitting right above the glass part of the tube. That would mean if I move the coils on the wire here, don't break the wire, Jim. If we move it away, we lose the signal down the wire. SDR. Yes. I get a little closer to the tube, I get a little more signal on the SDR. So that's what's happened. The amplified signal is radiating out of the tube. It would be, I guess, an electrostatic thing happening. I mean, that's not much of a coil I've got on the SDR. Now, next question. Is that for real? What exactly is that showing us now? That's showing us that the sweep signal, as it passes the tune point, is boosted extraordinarily. Perfect. That's exactly what I'm after. Now, the other thing we want to see in here is the local oscillator. We're tuned to 15 megahertz. No, we're not. 14. We're on 14 megahertz right now. And it looks like the tune point is way off because 14 is way below. It's way down here. It's not even on the screen. little hard to believe because I did an alignment and you wouldn't think it would be that far out. Also, the sharpness. It's giving us a false notion of the sharpness because what we're really seeing is the boost. Yeah, it can't be that sharp, can it? Can it? Now what do we do? Again, going back to, have I disturbed the radio by doing this? And what about this? We're on partial power here. Let me put it on full power. Oh my, what a change. So what has happened here, I'm going to turn down the radio a bit here, is the signal going to the SDR has gotten a lot stronger, especially this peak right above my finger here. And the SDR in response has its own level control, volume control, whatever you want to call it, and it's turned everything down. And so consequently the main sweep looks weaker now, even though I've done this. It hasn't really gotten any weaker. What's happened is the signal here has gotten much, much stronger. That's interesting. Just from the shift in voltage, we're at 110 volts. Before, I don't know what we were at, probably 92, 93, something like that. That's pretty dramatic. Okay, can we do something with this now? So what we would want to do, oh yeah, I gotta see the local oscillator. Now, since we're tuned to 14, the local oscillator should be, jeepers, is it above or below? It's going to be above or below by about 500 kilohertz. So 14 should be 13.5 and 14.5. Something should be around one of those two. So, well, we can't see 13.5, it's way down. I'm going to move this to the right. The whole thing going to the right. Okay, I'm going to move the tuning thing over here. This is probably the local oscillator here. 13.8. And this is the front end tuning point. And these two guys should be 470 kilohertz apart for the radio to work well, I believe. So that's 14.9, 13.8, it's almost 13.9. Ooh. It's double. That's double 470. Well, maybe that's just a coincidence. So I can move this around with the oscillator adjustment. I can bring it in line so that it is the 450, 470 away. But we got to consider the front dial setting. It's really about the front dial setting. Okay, and I still haven't moved the light bulb to correct the little light line here, so we're still doing this roughly. I'm going to set this right on 14 on the light line. Okay, that's 14. Now, well, that was curious what we saw on the SDR. So I got a big problem here. See this thing in the middle? And you see how this is really a mirror reflection from this point. If you come back this way, you see this pattern of signals, and you go this way, you see the same pattern with an extra signal. And if you go all the way here and all the way there, it looks like a reflection. This is here, this little rampy part, and the rampy part's here. I think this is false. You can see this signal is going right through the roof here. Hey, maybe I can cut it back on the antenna. Wow, that's no signal. Let's make it absolutely no signal. I'm going to turn this right off. Okay, there's no sweep. We have no sweep. What? What am I seeing here? Two versions of a local oscillator. No front end tuning at all. Maybe I've lost my mind. 14 again. So let's put 14. Put 14 right in the middle here. Okay. I will tune the radio a little bit. We'll see what happens to that. It's going to jump back and forth. Glorious. Which one of these is for real? Is one of these real and one of these fake? So this is at 13,855. Oh, is it really? Whoops, I'm sorry about that. I'm gonna bang the microphone there. Let's try another radio. 13.8. 13,855. Well, I don't hear a thing. The other one, 13,855. The other one's here, 14,945. 14,945. There it is. So this one's the real one. The other one's a fake. It's an SDR fake. 14. Okay, so we'll pay attention to that now. 14,945 when the radio is tuned to 14. That's not good. This is way off. I'm silent because I've already done one alignment and it appears to have not worked out. Now, there's nothing I'm doing here to disturb this radio's operation. Well, let's see, I have a low impedance connection to the antenna. No capacitor in there. I should have put a capacitor in too. I need a very, very small one to fake an antenna. Let's do that. I have a fake antenna here in my tray. Let's just find the tray. Fake antenna. All we gotta do is just hook that up to the radio and this up to one way or the other. I'm not sure it matters too much. And that should make the signal generator look more like an antenna. And I'm gonna have to use clip leads here. Things are gonna get a little messy. Take this off. I don't have my clip on here. Yes, I can do this. Yes. Okay. Antenna. So, don't really know where all this is going to end up. Hopefully it's going to end up in a good place. And having fun. That's good. Ooh, what's that signal doing there? I wasn't looking at the SDR. As soon as I took that off, that jumped. Did it? Did this happen? Did it? Well, it's not moving the frequency at all, no matter how I hook this up, one way or the other. We'll try that. Okay, so it would appear that hooking up the signal generator has not disturbed what we're seeing on the SDR, which is the local oscillator. Why it's going up and down in strength? No answer, comes the reply. Going down in strength. Yeah, okay. Maybe it's some kind of beat thing happening. The beat frequency is like 1 cycle every 20 seconds. I don't know what that is. Look at that. Okay, that's something to keep in mind, because boy, that ever throw you off trying to do an alignment if that kind of thing is going on. Could be just an SDR thing. I don't know. Well, what just happened there? It's just me moving around? Am I doing that? Okay, so what I did there was I stepped back quickly. I think it's just a coincidence. Let's just let it come up a bit. Okay, I'm going to step back. Stay back here. No, it's nothing to do with me. I'm innocent on this one. Wow, this is really getting quite sloppy, so to speak. how did this get aligned incorrectly? Or did the alignment drift after I did it? Or I just never got it right and didn't realize it? Because I was doing things with my ear, but wow, this is way off. So what we want to try to do here, assuming what I'm seeing is the local oscillator, well, we can find out easily if I just disturb the local oscillator a little bit. So the shortwave band is down here. Well, that sure disturbed it. So I don't think it's any doubt. That's the local oscillator. It can't be the front end tuning. Well, how are we going to see that front end tuning now? It's possible my SDR, its automatic volume or level control has just quelled things to the point where we can't see the fine stuff that is there to be seen. I turn the radio off, get rid of the local oscillator, or I could short out the local oscillator, I could get rid of it. And now that's not a bad idea. It's something I seldom if ever do, interfere with the local oscillator. What's the easiest way of doing that? Ground the grid. Ground the oscillator grid. And would that hurt the radio? I don't think so. Ground the oscillator grid, get rid of the oscillator, and then the SDR sensitivity will come up, and then we'll see the front end tuning. That is a procedure to get rid of the local oscillator at times. Doing this kind of work is just something I don't normally do. Let's see, I have a tool that would be useful for that. And where has it gone? It's just a big capacitor. Big honking capacitor on a stick. Well, I don't see it. I don't know what I've done with it. Okay, so we're not going to use the capacitor on a stick here. I'd have to think about which pin it is. And unfortunately, it's on this tube that I can't get access to the base easily. It could be just grounding perhaps this oscillator adjustment. This is just in parallel with the oscillator capacitor, tuning capacitor. I think you just ground this. And which side would you ground? You ground the non-grounded side. So this side's grounded, this side's not. We'll ground it and say goodbye to the local oscillator. Should I do it with a capacitor? It might feel better. So I have a capacitor with clips on both ends. Yes, I do. I do. Clips on both ends. First I'm going to clip on to the actual connection, and I think what we'll see is the frequency just shoot off into some other area. Now interestingly enough, that's really all. Oh, took my hand away. Oscillator came back at a different frequency. So let's actually ground it now. This way. Boom! No, don't get any booms. We have killed the oscillator. It's now. But I'm still not seeing the effect of the, well, because I got the sweeper off. Put it back on. Crank it up. Hot diggity dog. Okay, so we can see a little bit of the effect of the sweep. If you look down here, you can see the limits. The sweep starts here, and it looks like it ends right about here. And the local oscillator was somewhere in here. I didn't mark it. I should have marked it. Let's do that. So I'm gonna release the hounds here. Oh, don't snap in there like that. I'm gonna mark this. Well, son of a gun, if it isn't marked already. So that's right on the oscillator frequency now. 14949. I'm going to kill the oscillator. Oscillator is dead. Front end tuning. Hello, front end tuning. So I see nothing. So I'm going to try to widen out the sweep here. You might lose everything at this point. Okay, sweep is widened out. The sweep power is maxed out. There's no more juice to stick into it. Although I'm running through this. What if I get rid of this? No. That's better. And it would not disturb the local oscillator, and it's way over here. It could disturb the front end tuning, I think, what you're doing there. Let's leave it like this for more signal. Find where the front end is happening. Where's the front end tuning? Anybody see a curve in that at all? Some kind of curve? Let me stop this. Does it paint a curve? Now, it might not be much of a curve. Boy, oh boy, nothing really. Like, there's a little bit of a bump here and a broad bump here. So what I'm going to do is I'm going to put on the decay. I recognize one of the bumps is actually lined up with the tuning point, with the local oscillator, actually, not the right spot. I'm going to turn on the decay. And I don't want to tune the radio too far. Well, maybe the tune point's way off, so I'm going to tune the radio slowly. Oh my gosh, now did you see that pattern? I'm going back. It sure does seem to have a bit of a peak. But there's, again, it's got this reflective quality to it. So the SDR changes operation up around 20-25 megahertz. You have to switch to a different kind of decoding. And if you don't, you get weird results. Is that what's happening here already? 15. Let's try it. I'm going to change the way the SDR is decoding signals. I don't think it's the right thing to do, but I'm going to try it. So here I'm using direct sampling. I'm going to switch to quadrature. And we'll see what happens here. Not looking very good. It's showing just nothing. I think that's because it's incorrect to do that. So I'm going to go back to Q branch. I hope it's just a little more distinct than it is. Is there something else I can do here to pick it up? What happens if I lift the ground here? Oh, that picked it up a lot. Okay, let's do that. We'll leave it like that. Now look. I wouldn't say there's a tune point in there or a peak or anything. It just looks like a mirror image around the center point here, which I don't like. I don't like that. You can kind of see it in here too. This is not going so well. Let me expand the sweep a long ways here. Before we couldn't see any peak anywhere. So there's a curve here, like that. I'm going to turn off the delay. There's a curve there. The curve is sort of hanging around, right around, say 14.3, and the radio currently is tuned to just below 14 on the dial. So I'm going to move this way off. Way off. Okay, we're going down to like 10. So the radio's tuned to 10. Will this just flatten out then? I will turn on the decay again. No, it's got that same curvy look to it. And this weird thing going on here. Something is not working out here at all the way I would hope. It's certainly not in any position to make any adjustments on the radio, which is still operating. Picking up the signal in a different spot or in a different way. So we could look at the signal coming out of the IF. it's reflective of what's going in. Well, we would not actually see the tuning point that I'm after, the tuning curve, response curve for the front end. So the output of the first tube, the mixer tube, should contain it. So what if I go for the plate circuit of the output tube, of the first tube, and try to look at what's on the plate circuit of the first tube? That's a little bit more dangerous than what I'm doing now. We're looking at a direct connection. I could put it on the scope. Could switch to the scope at this point. Could switch to the scope. It's high enough impedance. I'm sure we can put it on a plate circuit and not throw this radio off. If I get at the plate circuit, that would take some fishing. The tube itself is mounted so you can't get at the pins. So I have to figure out where the plate is going to and what wire I would hook up to here. Sounds to me like it's time for coffee. So involved. I thought this would be kind of simple. It seemed to work nice on the lower frequencies, but up here. Okay, so for the first time, all this time looking at this radio, I now realize that this is a great big long terminal strip here, all the way along. And they've used it for making all kinds of connections down into these tubes. So one of these tubes, the tube I'm interested in, the number 1 tube, is up here, way up in here. But wires from it are coming out of here. And where are those wires going? One of them is going into the primary of this IF can here. So if we follow that. Well, what I'd notice is there's a red wire coming out of here. And it's coming right up to this terminal. And in this terminal, who's hooked up to who here? This red wire. This is probably B plus supply going through the coil, coming out. But how does it get down to that tube? How do you get to the tube there? Well, maybe this wire. What I can do is I can just look for B plus on these 2 leads. Which 2 leads? Really? Yeah, this wire coming from the tube area, terminal, another wire going in. Let's check this one for B plus. If there's B plus on there, that might be a good place to go hunting for the output of the first tube with low impedance, and I can hook up my scope to it. Okay, skip the coffee for now. Let's get on with this. Radio's switched off at the moment. So I'm going to be using this meter here, which is set to positive 500 volts, full scale. Turn the radio back on. Still have the oscillator shorted, that won't matter. Can we find a big fat voltage on here? Well, my meter's gone backwards here. What's happening there? Just warming up, I guess. Okay, here we go. Watching this meter here. There we are. That's probably the plate. We go over here. That's probably the plate. That's a plate of another tube. I think this is the plate connection. So we'll put the scope on there. Put the scope on there. Okay, I'm gonna. Camera angles here won't be very good. Camera shots, but for now it's good enough. Okay. Now this is being the sweep here is coming from the sweep generator, which is handy. I'm going to put the ground on, and then I'm going to connect. I'm going to touch this terminal up here. See if we get any fireworks. We are on times 10. And this is on AC only. And we're going to put it up 2 volts per division. What do we see on there? Can't see much of anything. Okay, let that hang. Now the signal may be very low. Okay, there's something there. What is that? Not sure what to make of that. So this is sweeping in accordance with the sweep going on over here. So yeah, I'm not sure how to interpret that. I don't know. Let's tune the radio, see what happens. Anything happening? Nothing happening. Back to where it was, 14. Oh, I'm down at 10. No, let's go up to 14. Some kind of DC variation here. So if we flip this onto DC, go this way down like that. DC right off the screen. 5 volts per division that's gone off the screen. Tune now. And nothing's happening. That's 5 volts per division. 0. I have a 0 button here. Don't I have a 0 button? I thought I had a 0 button. Beam finder inversion ground. So that's the 0 point. Let's just put it right here. Just doing a voltage measurement, doing a reality check. 5 volts per division. We're 1 division up. 1 division up. 1, 2, 3, 4 and a half. 4.5 times 5 is only like a 90 volts. 90 volts. Just doing a reality check here. 90 volts on here would be, that's a 150 scale, 90 is about here. Do we get the same thing? No, not at all. So, reality check. So now we're on the 500 volt scale. That's a very high voltage here. 200 volts. 200 volts, but I didn't get that on the scope. Why? I'm not reading this right. 5 volts, and for sure it went from there to there. 1, 2, 3, 4.5. 4.5, 5 volts. 20. Yeah, you know what? I didn't stop for coffee, and look at the situation that's developed here. If I ever gone down the rabbit hole, I'm way down there. Oh my gosh. Yeah, let me stop for a minute and clear my head. Okay, two sips of coffee and I got a really crazy idea. So we have this effect in the front end of the radio where the radio is peaking up the signal. And it's doing that at the RF frequency. So in this case, 14 megacycles. It then goes through the mixer tube, frequency converter tube, and it's converted down all the way to 470, in that range of 470. So wouldn't the front end tuning peak also be converted down to 470 rather, and be visible under the right circumstances in the output of the IF? He says, asking wistfully. There's a lot of problems with this. I think the IF is a little thing like this, and the peak that's being converted is a big broad thing. I think that's might be So yeah, basically, this approach I'm trying is not working out well. Well, and I only had 2 sips of coffee, and I thought, wow, brainstorm. And I should have gone for the 4th and 5th sip, I guess. There are lots of interesting things to see coming out of the IF of a radio like this. You know, if you move the front end peak to the proper location, the IF output goes up. There's no doubt about that. So we look at the IF output, and we tune the front end, we should see it go up. It's really no different than using a voltmeter, except it's visual. So you should move the whole show to the output of the IF in a low impedance, unsensitive spot where I can hook up equipment, especially this guy here. Actually, that's not much of a change. I just have to, wait a minute, no local oscillator. Nothing's getting converted. No local oscillator, nothing gets converted. I gotta stop for a bit, I really do. Okay, something did come to mind here on the antenna input. So I was operating the radio with a loop antenna using this guy here. But I've left the grounding link in the loop antenna position. I had not returned it to where it should be for injecting signals into here. I was using a regular antenna, let me put it that way. So we're going to take this off, get it out of the way. Swing up the ground here. This may make a big difference. Okay, anything happening anywhere? I don't. Yeah, big difference. Okay, like having my fingers all over something like this. There we go. And what kind of difference did that make? No difference at all. Okay, yeah, it's. Oh boy. Okay, stop again. Okay, an interesting question would be, did I really connect up to the plate circuit on the tube? So I'm hooked up to a wire here that's going down to the tube. It's on. I can see it. That would be pin 1, 2, pin 3. Pin 3 of a 6A8. Pin 3. Pin 3 of a 6A8. 6A8. Pin 3. Here it is. Pin 3. 3 is the plate. So I'm definitely on the plate circuit of the first amplifier tube. Out of that would come everything that's on the grid. The thing is, it's the plate is feeding, or is it has a tank circuit on it. You know, tank circuit. The impedance of this is low when you're far away from the resonance point. This thing's designed to resonate at 470. In fact, tuned it to resonate at 470 kilohertz. And this is a 14 megahertz signal coming along here. What it sees at this point is pretty much a short circuit. Down, so I think. But it doesn't go to ground. It goes to resistor here. It goes all over the plate. Oh! There's a capacitor grounding it here. So that ground would be just, from 14 megahertz, this wire appears to be grounded. So I'm looking for a 14 megahertz signal here. I'm never going to see it. It's too weak compared to everything else. Yeah, let's just check that again. It comes down through here, over here, down here, all the way over to here to find this capacitor, whose value is is difficult to read on this page. Oh, you know what? That capacitor is electrolytic. That's probably the one that's up on top. Well, it doesn't matter. If it's electrolytic, it's large, and it's designed to really clamp the voltage down, the signal down to nothing. So, yeah, nothing in here. The resonant frequency, when 470, if there's a 470 in here, when it gets to the tank circuit, it finds this to be a very high impedance. This thing rings like crazy, which is why you can't push stuff through it, and it feels like a high impedance to the signal coming, because it's kind of full up, sort of explained. And that causes heavy currents to flow in the resonance causes heavy reactive currents to flow in the coil, and that's how the energy is passed on that way, even though there's a ground stuck just below it here. So at 470, it doesn't really see the ground, it sees this coil. Kind of. Of course, it doesn't see anything, it's blind. Electricity is blind. Like justice. Well, so I'm barking up the wrong tree, that's what that would say. Barking up the wrong tree. Where else could you find it? Where else could it be? Well, only, and what I'm talking about is this tuning response at 14 megahertz from the front end, from these front end stuff. Only on the input coming in. And if I stick anything on here, anything serious, it's going to detune the radio, and I'm going to get false results anyway. So I'm doing everything I can to get around adding this extra capacitor as in the instructions down here and doing this. I'm trying to find a way around this. A better approach, in fact. So what I'm really looking for. And the lower frequencies seems to be working. My approach, the upper ones, no. Wow. Okay. I'm going to fill my coffee cup up for coffee cup number 2 and ponder this a little more. Okay, just before I get going here, does your cat talk to you directly? My cat uses body language. Let's take a look at him. See him down there? What he's doing is he's in position to go up the stairs, which is on its way outside. He's giving up on that now. He's going to come and directly approach me. He wants to go up. He probably won't. He won't come in because he wants me to go out of this room. So he won't come yet. And that's typical of a cat, isn't it? You want to go outside, Peanut? Is that what you want to do? And he's looking at me going, can't you figure it out, you stupid human being? So stupid. It should be obvious. I want to go outside. Okay, I got a good idea here. I will come back and we will look at the good idea. Poor cat's had his day ruined yesterday and today because my neighbor is having a new roofing tiles put on his roof. And the guys are up there hammering away, using the hammer guns. And the sound is disturbing to my cat. He doesn't like it. It's a very unusual sound. And he doesn't like it. So stuck his head out the door, heard the pop, 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 and he just came back in. Poor guy. So what was the breakthrough? The breakthrough was, it's not really a breakthrough. I'm having trouble on the highest band. Why don't I give up on that for now and see about using this technique on the lower band, the lower shortwave band, which is actually within the range of the sweeper. The sweeper goes up to 5 megahertz, and the radio currently is tuned to 4. So the primary sweeper, not using a harmonic, which is just another complication in this whole affair. And there you can see. What do we see? We see clearly a bump here. Now, this is monitoring, or the SDR here is monitoring the input to the first tube. So this is kind of the output of the antenna tuning system, if you like. And this is probably the local oscillator here, because it's so big. Let me just tune the radio a little bit, and we'll just make sure. Yeah, for sure, that's it. So you can see the two things move together, right? This is what alignment is all about, getting these two things to move together. So in fact, their distance is exactly 470 kilohertz. So let's put this one on. Let's put this one on 470. Get some easy math going here. So the red line is right on 470. Now I'm gonna tune the radio right on that. Okay, and if everything is good, this peak should be right at 4 megahertz. But it's not. It's in the wrong place. So, question comes now. Is it in the wrong place because I've disturbed this radio? Again, this is the question. I have the scope still connected. By the way, there is a little something to see on the oscilloscope too. If I just do this. I'm not going to comment too much on it. See that there? There's something there. Yeah, but I'm not gonna. I don't want to. Let's just stay with the SDR chip. One of my problems is I put too much on my plate all the time. Think back to the early experimenters, back in the 1800s, 1850, in and around there. Things were really picking up with electrical experiments. Guys were working with coils of wire, magnets. They're trying everything. There are guys who we wouldn't even know about because they never got anywhere, who spent their entire lives experimenting with a couple of coils and some batteries and just trying to get something to happen, and would fail. Their entire lives spent doing that, trying to make a motor, come up with a way to make a motor. There must be some way of doing this. Let's try this, let's try that. And so when I think about those guys, my own personal frustrations with doing this go way down. I say to myself, well, although I don't plan to spend my entire life on this radio, surely I shouldn't be upset if it takes an hour or two to sort something out. Okay, let's disconnect the oscilloscope and watch the SDR. And did I do anything here? It should not affect it. No effect. Okay. Affect the sound coming out of the speaker. Yes. Yes. A little bit. So we can leave that connected. Now, what about how I've done this with this coil? I will move the yellow crummy coil around a bit, and we'll just see if that somehow moves the resonant point that's shown on the SDR around. So what if I just grab this and just move it around? So it's getting less as I get away from the tube. I get it closer to the tube. No, it doesn't seem to be causing it to move around left or right. Is this really true? So if this is true, I'm in a really good position to align this band. So let's take a look at a few things. First of all, let's set the oscillator correctly. We'll try this. Oh, you know what? I still can't do it. I don't have the light in exactly the right position. So we're still fiddling around. That's okay. Let's fiddle. So we want the dial is set to 4 megahertz. Assuming the pointer light was correct, 4 megahertz. The local oscillator should be at 470. You see the local oscillator is off. It's up here. It should be down here. So we're gonna move it down there. We're gonna move it down there. Here we go. Down to a red line. Here. Right there. So now the local oscillator is operating properly in conjunction with the dial reading, even though the dial's off a bit. We can fix this all up later. Now the question is, the radio is now tuned, making sure, to 4 megahertz right on, and the tune point, look at that, it's right on 4, ever so slightly off. So we can adjust that here. Okay, let's move it around a bit. There it goes. Bring it back. Stick it right on 4. Now, unfortunately, I'm aligning the band that's really got nothing on it to here. So reviewing this now. The local oscillator is running at 470. The IF is tuned to 470 kilohertz. The dial is reading 4 megahertz. 470 kilohertz away is 4 megahertz, and the front end is peaking right there. So to me, this radio is beautifully aligned, at least at 4 megahertz. We don't need the scope connection because we're getting away without it. Now, why can't I do exactly the same thing on the higher band? First of all, it's out of the range of the sweep, so I'm trying to do it with a harmonic of the sweep. Okay, so I should be able to do that. And it yeah, kind of running out of words here. Well, let's go up there one more time. One more time, just for fun. Go up. Okay, now we're way up there. Way up at... We'll do exactly the same thing I just did. We'll do it at 10 megahertz. Because that's easy figuring. 10. Okay. Dialed on to 10. Go up to 10 here. So 10 megahertz is right here. The radio's trying to tune stuff here. To tune stuff here at 10, the local where's the local oscillator? The local oscillator should be at 10,470. Where are you, man? Did this radio stop working again? Is that what I've been really chasing? Oh my gosh, I don't. I've got to short it up. Wait a minute. Wait a cotton picking minute here. Oh, shame on me for saying that. Shame on me. Shame on me. Trying my best to eliminate that phrase from my repertoire. So I've got the oscillator shorted, but it's not switched to this band. So I don't have the oscillator shorted. What's going on here? Do I? Do I not? Well, I'll be a what? So dialed on to 10, still no, well, let's tune the radio. Things are moving. Appear to be moving way too fast. So the thing we see on the SDR down around here, that's moving. To me, it's moving too fast. I'm barely tuning the radio and it's racing across the... and of course, wait a minute, I'm in the wrong spot here. It shouldn't be at 10, it should be at 15. It should be at 15, too. Yeah, I've been in here too long this morning, clearly. 15. Ooh, there we are. There's Mr. Oscillator right there. Okay, let's try this again. So we're going to tune it to 15 megahertz. Wait a minute, you know what? I've been in here too long, there's no question. But let's carry on. 15. 15's right here. I think that's 15 there. So if we're 15, we'd expect the local oscillator to be at 15,470, which is way down here. 15,470. What's it doing way up here? And I thought I aligned this reasonably, didn't I? Did I move it already today? I don't think so. Well, let's bring it in to where it should be. Once again, just checking to make sure I'm not reading this wrong. It's definitely 15 megahertz. Local oscillator. I did have this on the right spot earlier when I was shorting it out on this band. Stop the mumbling, mutter. Really in here too long. So we want this to be at 15,470. Down to the red line. 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 Okay, so to tune in 15 megahertz, the local oscillator is in the right spot. Now, how did it get so far out? Me would be the answer, I'm sure. Now, is there any chance of seeing the front end tuning in this radio? Once again, the local oscillator is causing the SDR to essentially... Now, the warning in this radio is if you tune the antenna, you will accidentally adjust the local oscillator at the same time. Well, I'm going to knock the oscillator right out. Does that cause the tuning up here? Does it work in reverse? Knocking it out. Knock the puppy out. Okay, the local oscillator is gone. Can we see? So now the trick is to get the sweep coming through as strong as possible. Get this out of here. Hook my signal generator directly again. Antenna input. The sweep is, what's it doing here? It's going from 3 megahertz to 5.1. 5.1 times 3 is 15.3, wouldn't it be? 15.3. So it should be going all the way up to 15.3, stopping in here somewhere. Look, wow. So I'm looking down here, can't see a thing really, nothing clear. So I'm trying to see this. I should be able to see this. It's just... Oh, I don't have the power up full. Give it a full Monty there. Can you hear it? Can we? We don't hear it in here at all. That suggests the sweep is just not doing the job here at all. So what can we do? We can't raise it above where it is, 5.2. So we could extend the bottom. Pretty clicky. Wait a minute now. Put it like this. Go like that. Now we're starting at 5 megahertz and we're going to 5.2 megahertz. Just a tiny little sweep. There it is. Excellent. Okay, so been here before, but we're going again. So now I want to expand that sweep. Do I really? What do I want to do? I want to sweep the tuned frequency and see if there's a peak. The tuned frequency is 15. We're sweeping way up above it. So we got to take it down, take it down, take it down, take it down. Okay, and I think can I take the top down? Trying to focus the sweep right into the critical area. There we are. Now we got a clear indication on the SDR where the sweep is occurring. The sweep is going through 15 megahertz. I don't hear anything coming out of the speaker. I have the local oscillator off, so it can't convert it. Can't convert the sweep up into the IF frequency. So I take this off. We should hear it. Right, I hate the predictions. It's a winner. We can hear it. Okay, guess I need to extend an apology for that, but I'm sure everybody get back on your chairs. Yeah, that just about blew me right out of here. Should have thought of that, but I didn't. Okay, excellent. So now where are we at? So we're looking for the peak inside that 15 little sweepy area, here. We're trying to see a curve, but we're not going to see a curve. I got to stretch it out. I got to stretch it out. Can we stretch it out? We can go up a little bit. We can't go down. going to be about it. Now, conceivably, the peak is outside of the sweep area because the radio's not aligned right, and that's why we can't see it. Now, here, interesting thing. I'm going to adjust the antenna coil. We'll see if the local oscillator moves. As this is what the whole thing is about. Turn this down. Turn this down. Oh my God! It's almost noon. I got like a 3-hour video here. Here we go. Moving the local oscillator, not on purpose. Moving the front end tuning. There it goes. Hey, what's going on there? Look at that. Did you see that? Through the sweep area. Look at that. Bingo. So I've now got the front end. This is working. I got the front end tuned properly. The local oscillator has gone for a walk. It's not. Oh, it hasn't really. Let's see again. So 15. On here. We're tuned 15 megahertz. We've got the front end peaking at 15 megahertz. And we got the local oscillator running at 4 seconds. Perfect. This is perfect. Perfect. Okay, now let's take this off and see if anything terrible happens. Pretty interesting. The local oscillator shifted just a tiny amount. Put on an antenna. Give this guy a go here. I'm done for the day. It's been a tough slug to get here. Okay, this is my outdoor antenna for sure. Yes, it is. Turn the volume down. On you go. Ooh, lots of volume. Okay, now, the question is, can we pick up anything up here on this band? What is up here to pick up? 15770. There's a few strong signals that, oh, you gotta turn this guy off here. We don't want that going anymore. Even though it's not connected, it was still being picked up. That's good. So here we go. 15. Heading for 15770. Right in here. Come on. Anybody? How about WWV? That'd be beautiful. Down in frequency, European band, right in here. Nope. It's picking stuff up. Shortwave band right in here. Nothing. There could be nothing to hear. Getting close to 9.33. WWV. 10 megahertz. Long time of day. 9.3. Come on. The case. Kind of a disappointing result. I was really hoping for the magic there. Let's try this guy. Go 9330. That's what's there. Strong signal. Strong signal, 9.33. Oscillator going, everything's good. There he is. Fading signal. That's why I was having trouble. Now it's tempting to adjust, let's say, the antenna adjustment on the radio, but it will cause a local oscillator to drift off. What we could do is we can look at this on the SDR and see if we're in the ballpark or not in terms of the alignment. So we will do that. Okay, so I just have to go down here. Okay, I got to do some serious calculating here. Let's turn this down. You can see the local oscillator sitting right here. And its frequency is, we'll call it 9800. That's easy calculating. And if you subtract 470, what we're hoping for here is 9333. I'm going to do it with a calculator. 9800 minus 470. No, 470. 9. Oh, you can't see that. That's what we're tuned to. That's what we're listening to. It all worked out. And on the dial, trust me, it all worked out. We are basically right on 9.3. Except the dial's wrong, the pointer's wrong. Oh man, what a journey that was, but I got there. Okay, learned a lot of stuff about how to do this, how to make this work. Don't need the scope. Okay, well that's it for today. What did I succeed in doing? I think I succeeded in devising a method of aligning this radio. Does not involve the extra capacitor. Gives you, I think, probably a better result, a better feeling about the result too. It's not quite as mysterious because it's exposing the local oscillator frequency, exposing the front end tuning to be seen visually and all that. I like that. So now I've got a good tool, more or less, or approach, maybe is a better word. Tomorrow we'll finish the alignment on this radio using this method. And that's it. Oh wow, it's a long video to get here. Thanks a lot for watching, and thanks a lot for the super thanks. We'll see you tomorrow.